Today we will be talking about what can engineers do in the event of an earthquake. So what is an earthquake? The earth crust is made out of tectonic plates. They are constantly moving away or towards other plates. Sometimes their edges catch up while they continue to move. Pressure is gradually built up and it is being released in the form of shock waves, traveling through the ground, which we call earthquakes. Although this energy can't harm humans directly, but the damage it causes on buildings can lead to its failure, threatening people who are within or nearby. We're going to analyze the 2017 Mexico earthquake to understand how buildings are affected under an earthquake. As shock waves arrive below the building, the base of the building is being shaken while the building itself tends to resist this lateral force. Hence, the building is displaced. Damage is being dealt on the building each time a displacement occurs. Here's an affected example in Mexico City. The building after the earthquake had its ground floor completely failed, while the upper floors appear to be less damaged. The building was very likely to have a weak column strong beam design, which doesn't provide an ideal earthquake resistance. A model has been constructed to explore the possibilities to improve the building in the previous picture, and simulating the behavior of the building under an earthquake. Braces have been added to the ground floor. This increases the connection between walls, hence resistance to the lateral force as well. Reinforcements have been focused on columns rather than beams, raising the overall building ductility. Other than lateral force induced by earthquake can damage buildings, landslides can also be triggered on slopes by earthquakes pouring over buildings. Granular soil slopes have a maximum inclination under gravity, called the friction angle. When an earthquake happens, the maximum inclination of the slope can have is reduced. The new stable angle is called angle of repose. If the angle of the slope becomes greater than this value, the slope becomes unstable, leading to failure. Safety factor is used as a reference to show which slopes are stable. This is the ratio between the angle of repose and the angle of the slope. We can use this ratio to find out which slopes are safe to construct buildings next to under a certain magnitude of earthquake. We also decided to find the angle of repose of the slope that can achieve a safety factor of 1.5 during the 2017 earthquake. A box of sand sample is prepared. Then a measured force is applied to represent the peak gravitational acceleration, and the angle of repose is recorded. Next, we plotted peak gravitational acceleration against the angle of repose on the graph. A trend line can then be drawn. At last, we'll use this line to find out the angle of repose with a safety factor of 1.5, which is 24 degrees. And now we're going to conclude what can we do in the event of an earthquake. The greatest support we can give is to reduce the number of casualties by designing buildings with a higher earthquake resistance. To do this, we need to have a better understanding of how buildings fail, what can we do to improve the ductility, as well as identifying which areas are safe for buildings to build on, and applying these knowledge to aid our design. Thank you for your attention.